Hello, dear participants and colleagues. I hope you all are doing well. Welcome to the session 8.2. So before we start, I would like to remind you that we have a limited time, so you are kind to finish your presentations within 10 to 12 minutes. So we can start based on the list I have. So in the first place, Kyung Lee. Are you here?
Yes. Hi, everybody. I'm Cheng Li. I'm the speaker for our paper. Our paper is self-balancing robot with reinforcement and control use DDPG. Um, so,
Can you share your screen?
sorry, I'm not sharing. Let's see. I'm not very familiar with Zoom. Be using Teams. Sorry about that.
No problem. You got time.
Mm, am I sharing?
You are trying, but yes, now we can see it.
All right. Let's start. So our paper is self-balancing robot with reinforcement learning control using DDPG, and here's overview. So we enable the robot to learn the optimal actions to maintain balance by accumulating rewards based on the duration it stays with predefined pitch angle. So we implemented Q-learning, deep Q neural network, and DDPG, and we'll elaborate on that later for the future slides to control self-balancing robot model with PyBullet simulation platform. We compare it to the original paper that we based on their research, and we add a couple more algorithm to enable continuous control. And here are our methods. We originally implemented in with ROS2, but one of our researchers was not able to enable it on their computer. So we switched it to I'm sorry, I got a little bit code, PyBullet. So for our algorithm, we begin with Q-learning and deep Q neural networks, and later transition to DDPG and actor-critic algorithm to handle the continuous action space needed for real-world application. And then our simulation environment is by PyBullet for robot communication and control. And then we use our programming language is Python with TensorFlow. And the robot shape is two wheels and a cart. And here is our robot structure. We have a whole chassis and two wheels. For Q-learning, our algorithm, we start by setting up a few key inputs: the number of states and actions, the learning rate, and the discount factor, and the exploration rate, and the exploration decay, and the number of and the number of training episodes. From there, we create an empty Q table, and this table will store the robot's understanding of how good each action in each state. Each episode begins with a reset of environment. We zero out the reward, the loss, the count of stable steps, and the total steps. Then we take the robot's initial pitch angle and angular velocity and convert them into discrete state. The discretization makes the Q table manageable, since continuous values would make the table far too large. During this episode, follow an action selection rule as epsilon greedy. We with some small probability epsilon, we choose a random action. This encourages exploration. The reset of time, we choose the action. The rest of the time, we choose the action with the highest Q value for the current state. This drives improvement over time. Once we choose an action, we apply it to robot. The environment simulates the fact and returns two things, a reward and the next state. If the robot stays within the safe pitch and go, we count that as a stable step. And we track absolute difference between the target and Q table, Q value as a measure of loss. If at any point the robot's pitch and go goes past the termination limit, we end the episode early. Otherwise, we continue until the episode naturally finishes. At the end of the episode, we store the total reward, the average loss, and the stability score, the number of steps. We also slowly reduce epsilon so that the robot explores less over time and relies more on what has learned. In summary, this algorithm lets the robot learn how to balance itself without any predefined control strategy. And it builds it builds that skill entirely through repeated experience guided by a simple reward signal and steady updates its Q table. And then let me see. Am I freezing?
Is there a problem?
I'm not sure if I'm sharing. Just give me a minute.
We are listening to you.
Okay. I think it froze. I'm so sorry. Okay. Next slide. Sorry, am I okay? And then we implement deep Q learning. We start by setting up the key pieces, the size of the state and action spaces, and the learning rate, the discount factor, and the exploration rate, and the decay rate, and the batch size, and the total number of episodes. We create three important components: the main policy network, the target network, and a memory buffer that stores past experiences. Inside the episode, action selection works the same way as before with a small probability. We explore by choosing a random action. Otherwise, we choose the action that gives the highest predictive value from policy network. Once we have enough samples stored, we draw a mini batch and update the network. For each sample, we compute a large value based on the target network and apply a simple squared error loss. We backpropagate that loss to update policy network. Every few steps, we copy weights from the policy network into the target network. This stabilizes training and keeps the network from chasing a constantly moving target. If the pitch ever exceeds the safety limit, we stop the episode. Otherwise, we keep stepping until the environment ends naturally. By the end of training, the policy network learns how to keep the robot balanced through direct experience without relying on a lookup table. This version is more flexible and handles richer inputs and scales better as the target gets more complex. And then and then we'll walk through deep deterministic policy gradient, DDPG. So the setup begins with a replay buffer, an actor network, and a critique network. The actor decides which action to take, and the critique estimates how good that action is. We also create target versions of both networks, and these networks move slowly towards the main networks during training, which helps keep learning stable. Before training starts, we also set up noise process. This adds a small amount of correlated noise to the actions, so the robot explores smoothly instead of making sudden jumps. Each episode begins with resetting the robot and the noise process. The initial state comes from the robot's sensors, just like the earlier algorithms. And inside every time step, the actor picks an action based on current state. And then we add noise to encourage exploration. The robot applies this action and we observe the reward and the next state. We store the experience in a replay buffer. When we have enough data, we draw random batch from the buffer, which we using this batch, the critique computes a target value using the reward plus the discounted estimate from the target networks. The critique then updates itself to match this target. After each update, we softly copy the actor and critique weights into their target networks. This slow update step keeps the learning process from becoming unstable. Repeat this loop throughout the episode until it ends naturally. Over time, the actor learns to output smooth, precise values that keep the robot upright. In short, DDPG gives the robot fine-grained control over its movement, allowing it to balance with continuous action instead of discrete ones. It's more advanced method, but it produces smoother and more realistic control behavior. And here is our measurement matrix. We have cultimate reward and average loss, stability score, and then convergence time, and also episode length. And this is the measurement matrix for Q-learning. As we can see, it starts getting very stable after 300 episodes. And this is the measurement matrix for deep Q-learning. And deep Q-learning is a little bit tricky, and it's not extreme. It's not as stable as Q-learning, and it starts to get good results between 400 and 800 episodes. Here is the measurement for DDPG, which is very exciting, and then it starts to get very stable and self-balanced right after 100 episodes, and is significantly better than previous two methods, and the training time is also faster. And this is all about our paper. And thank you for listening. If you have any questions, please bring it up.
Thank you for your presentation. Any questions? I would like to ask a question for you. The question is, would you like to apply this to a real world problems, or you want to keep going on simulations or like rows or something?
We would want to break the third dimension, so want to apply it to a real robot. And we also already like doing research on the real robot designing. Would be very exciting to actually apply this on a real robot. Thank you.
Thanks. Thanks for your answer. So we can move on to next one on the list in the second place, Keeping Way. Are you here? Keeping Way? Probably not here. The other one is Tarushi. Are you here? I'm
Yes,
not
I
sure if
am here.
I.
Yeah, it's Tarushi Indra Kumar.
Okay. I'm sorry if I mispronounce.
That's okay. Is my screen visible?
Yes.
Okay. Yeah, so good evening, everyone. My name is Tarushi Indra Kumar. I am an electronic and telecommunication engineering graduate from General Surgeon Kottadawala Defense University in Sri Lanka. Um, So I will be presenting our paper, Autonomous Human Detection Drone for Disaster Response in Flooded Areas, which was carried out in accordance with the requirement provided by the Disaster Management Center in Sri Lanka. So my team members included engineer Mrs. P.N. Karnanayaka, TV Indrakumar, myself, HHS Hevaraji, and RDSS Somasivi. So, floods are the most frequently occurring and most destructive natural disaster in Sri Lanka. Locating survivors in such a situation is very important. So, traditional methods like rescue boats and helicopters require a lot of resources, human effort, and are time consuming. So, due to this, the Disaster Management Center highlighted a need for a reliable, technology driven solution with minimal human intervention. So, our project aims to address this issue by doing the search part in a search and rescue mission. The main aim was to develop a drone based rescue system which uses image processing techniques and locating survivors during a disaster situation. When it comes to our research objectives, we mainly wanted to implement a pre-trained deep learning model, YOLO V5, for accurate aerial human detection. Then we wanted to design a customized drone from scratch so we can achieve the stability and payload requirements as we needed. Then finally, to develop a transmission data transmission method for long distance to send the survivors' coordinates to the search and rescue team. So our scope included developing a customized drone, which is equipped with a camera. We have used a Raspberry Pi V2 camera and a microcomputer. We have used the Jetson Nano board for this purpose. And it also includes implementing a deep learning model, as I mentioned earlier, to test on detecting humans in disaster areas. And our scope also includes transmission of detected human locations to the search and rescue teams in real time using the LoRa technology. Let us go through a few literature review I have included here. The first image shows us how drones were used to assess flood situations and to arrange control measures. And the second image shows an image obtained through helicopters from a helicopter view. It is an aerial view during a search and rescue mission of the Hurricane Sandy. Then next we have a map created by GIS and satellite images. This shows buildings in flooded areas with damage claims and without damage claims. The next image is one of the most familiar methods we use, search and rescue boats during floods. The fifth image shows an Australian drone operator where drone images have been used to create maps of damaged areas and assist in rescue missions. Finally, we have a drone that is used to carry inflatable life rings for swimmers in distress. When it comes to the methodology of our system, once the system is up and running, when our drone is in flight, the camera on the drone will detect objects, and it will ask itself the question whether the detected object is a human or not. If it is a human, the GPS sensor connected to the Jetson Nano where the model runs will fetch the location of the detected human and will be sending the coordinates to the search and rescue team using LoRa communication technology. So this is a small video obtained using a drone from flying at a height about 10 to 12 meters during a flood situation in the south part of Sri Lanka. It shows how the pre-trained YOLO Wi-Fi model detects humans and with what accuracy. This is the model that was deployed on the Jetson Nano board for our drone as well. This is an image that shows all the hardware requirements that we needed to run the YOLO Wi-Fi model. The main part of this is the Jetson Nano microcomputer we used. We have used it due to its reliability and fast performance. And a MIPI CSI camera was what we used. It is connected to the Jetson Nano through a MIPI CSI port through a ribbon. And the LoRa module, which is used for the communication, is powered using an Arduino Uno. Also at the base station, there will be a receiver LoRa module as well. The one on the drone is the transmitter LoRa module. The GPS module we have used is Neo 6M, and a buck converter was used to level down the voltage that comes from the battery supply because the Jetson Nano board powers with 5 volts. This is a block diagram that shows how all the components are connected to the Jetson Nano. We have the GPS, the camera, the Arduino Uno, and the buck converter connected to the Jetson Nano board. This is how our drone looks like after assembling. The Big Sock flight controller, as you can see here, is at the top, and it is the brain of our drone. It is the most essential part for navigation. The GPS module of the drone. So this is a different one from what the Jetson Nano uses to fetch the location coordinates of survivors. This GPS module is used for the navigation purposes of the drone. Then we have the motors, propellers, which were all selected based on calculations. And the MIPI CSI camera I talked about before can also be seen here. This is a video of our drone in flight with the total payload. So for now, we have achieved a flight time of 10 to 15 minutes per flight, powered using two 2200 milliampere hour LiPo batteries connected in parallel. And the payload we have implemented for now is about 2.5 kilograms. This table shows the accuracy of the YOLO Wi-Fi model with the distance from the ground level. So we have achieved a greater accuracy at about a distance of 5 to 10 meters above the ground level with the camera that we have used. If we use more powerful and more reliable high resolution cameras, I'm sure with the model we can achieve more accuracy. So we have few limitations of our system as well. It cannot operate in adverse environmental conditions like strong winds and rains for now. We aim to develop this further and find a solution for this. And it is also limited to daytime use as we have used a camera which does not have night vision capability. Also, if we are to achieve longer flight time, we will need more powerful batteries, which means the payload of the drone is going to increase. So, and for this purpose, we will be needing more powerful motors. A few challenges we faced during implementing this was we faced several hardware damages, then difficulties in integrating the whole system together. The operating system was Linux. We faced several corruptions to the OS during the project. And then calibrating the drone for a stable flight was a bit difficult because the drone was a whole new concept for us, but we learned and somehow went through it. The camera resolution, the camera we have used provides 8 megapixel resolution, but initially we weren't able to achieve it, but somehow we sorted it out. The high payload also made it difficult for us to control the drone. But during the final days of our project, we somehow achieved that as well. Yeah, so that's it from me. Any questions?
Thank you. Any questions for this study? Thank you for sharing. No question, probably.
Okay. Thank you so much.
Welcome. So we can move on to the next one. Yağmur Demirkaya. You here?
Yeah, I'm here.
So you can start.
Okay. Hello, everyone. My name is Yağmur Demirkaya. I really appreciate you for coming here today. Today, I will present our study on forecasting flight delays. Flight delays have become a significant issue that affects not only passengers, but also airlines and operational planning. Therefore, being able to predict when a delay will occur and how long it will last is becoming increasingly important in this modern aviation. With the rapid growth of air traffic, delays should no longer be viewed as random events. They must be managed proactively. Achieving this requires powerful prediction systems that can consider both operational flight information and weather conditions. The main objective of our work is to combine operational data with meteorological data to generate more accurate flight delay predictions. This can improve operational planning and enhance communication with passengers. In the study, we used a large data set containing thousands of flight records. We examined departure and arrival times, delay durations, and several operational features. Along with these, we incorporated weather-related variables such as precipitation, wind speed, and temperature. By combining these two data sources, we created an operational and environmental profile for each flight. We then aim to predict the delay based on this profile. We also applied essential pre-processing steps such as data cleaning and handling missing values. Without diving too deep into technical details, let me summarize the models we used in the study: XGBoost, Random Forest, LightGBM, CapBoost, and LSTM. Each of these models represents a different approach. XGBoost and LightGBM capture complex relationships very effectively. Random Forest offers a more stable structure based on multiple decision trees. CapBoost is known for handling categorical variables efficiently, and LSTM, on the other hand, is a deep learning model capable of learning temporal patterns. We compared these models to answer a simple question, that is, which one predicts delays most accurately? Our comparisons show that XGBoost achieved the highest accuracy among all models. Its low prediction error suggests that it can be used reliably in real operational environments. Random Forest also delivered strong performance, though slightly behind XGBoost, LightGBM, and CapBoost. Performed below expectations, and LSTM, despite its temporal capabilities, did not outperform the best tree-based models in this dataset. An important insight was that weather conditions such as wind, precipitation, and temperature have a significant impact on delays, sometimes even more than operational factors. For our future work, we integrated the best performing model XGBoost and random forest like GBM, CapBoost, and LSTM into a web interface. Users can enter flight information and instantly receive a delay prediction. Such a system can be highly beneficial for airlines in their decision-making processes. For future work, we plan to include datasets from different regions and extend the time range. We also aim to incorporate richer and more detailed weather data to further enhance the model's accuracy. To conclude, combining operational and methodological data significantly improves the accuracy of flight delay predictions. Thank you for listening. If you have any questions, I'll be happy to answer.
Thank you for your presentation. Any questions? No question. Thank you again. But we can move on to the next one. Yasamin Akrami, are you here?
Yes, I'm here.
Okay, you can start sharing your screen.
Yes, can you see my screen right now?
Yes, it is visible.
So hello everyone. Today I'm going to present our conference paper's multi-client scenario-based reverse shell attack simulation on behalf of my co-authors. So, as the introduction, what is a reverse shell problem? So the reverse shell problem is that a reverse shell is a technique where a compromised machine connects out to an attacker's servers. So it's a connection that is not inbound and it's a connection that is outbound. And this bypasses the traditional firewalls which are typically configured to block inbound connections. So the research gap that we are focusing on right now is that most of the research are the defensive side of the attacks, and most of them are just focusing on the single client attacks. But the real world attacks are more complex, and they are using some command and control server, which is called CNC, to manage the multiple attacks at the same time with the multiple clients. So our research objective is to simulate a multi-client scenario-based reverse shell attack and design a novel simulation framework to implement and evaluate the results of that. And after that, the second objective that we have is to analyze the technical architecture that is required and how we can make a stable and concurrent session at the same time. And the final objective that we have is to increase the awareness and create a tool, a valuable tool for the education, for the red teaming, and for the research in the future. So in the literature review side, there were some literature review that we have finalized them, and there were some key gaps in them. The limitations of most of them was that they were focusing on one single client scenarios, and they lacked the scope of the simultaneous multi-client interaction. So we designed a system to fix this problem. The system architecture that we had designed is a CNC model. This system uses a centralized command and control CNC architecture, which is a client-server model. So we have different bases on that. The first one is a server. The server is an attacker central command node, which is implemented in Python. The clients are the multiple compromised victim machines. So we have one single server and we have multiple clients at the same time. The topology that we had used in this design is a hub and spoke model where all the clients are connected back to the central centers. And the technology that we had used is the Python socket programming. As you can see in here, this is our system architecture, and we had designed a multi-client CNC servers, and all the clients and nodes are connected concurrently to this server. So the core challenge is that the multi-threading models, how we can handle the concurrency. The main challenge that we had faced is how we can handle multiple clients at the same time without the server blocking them or freeze them. The solution that we had designed is a multi-threaded architecture. So we have two different threads. The first one is dedicated to listening and accepting clients' new connections. And the second thread is manage the interactive command shell and allowing the attackers to send commands and select the targets. Now, we have another problem at the same time. The TCP is a stream protocol, and it's hard to know where one message ends and when the next one begins. The solution that we had designed is a custom protocol. So each message is prefixed with a 4-byte header that states the exact length of the payload. So in this case, we can understand what is the message length, and based on that, we can continue, and this prevents the data corruption. What are the performance and the key findings of this project? We have successfully established a connection from the client and bypassed all the inbound firewall restrictions as expected. The system is maintained stable without the low latency, and at the same time, it's concurrent. And the performance is successfully prevented blocking operations by the firewalls, and the data is integrated. So the attack vector is that how the clients get delivered. So we have 3 different methods for that, which is the baiting, phishing, and spear phishing. And why it is so hard to detect? Because it's an outbound connection. It's not something that initiates from the outside, but it is something that initiates from the inside. And the mitigation and defense strategies that we are using is a technical controls such as the zero trust architecture, outbound filtering, and also the human and policy controls, which is increasing the security awareness of the people and the clear policies. In the conclusion, we have presented a high performance, stable simulation framework, and in the future works, we are thinking of adding, and we are planning of adding machine learning based detection mechanism at the same time. Thank you so much for listening.
Thank you for your sharing. Any questions for this study? You can ask freely. So no question probably. Thank you again.
Thank you.
So the next one is Muhammad Arslan. Are you here?
Yes, I am here.
Okay, you can share your screen.
You see my screen?
Yes, is it all?
Okay. Hello, everyone. My name is Mohammad Aslanul Haq, and I am a graduate master's computer engineering student at Middle East Technical University, Northern Cyprus campus. Today, I am presenting my paper on which is titled as Machine Learning Based Context Aware Segmentation for Binary Sensor and Human Activity Recognition. So this is the outline for my today's presentation. I will start with the sorry. I will start with the introduction, research objectives, background study, and then I will explain the data set which I have used, methodology, and our results and discussion. After that, I will end my presentation with the limitations, future work, and conclusion. So let's begin with the introduction. Human activity recognition from ambient binary sensors is central to smart homes, health monitoring, and ambient assisted living. It enables automatic detection of daily activities for personalized healthcare, anomaly detection, and energy optimization. A key step in her applications like it is segmentation, splitting continuous sensor streams into windows for feature extraction and classification. Poor segmentation leads to ambiguous activity instances and it degrades the recognition performance. So, despite this, people have been used fixed windows. It is remained dominant in smart home hard applications, even though it often misaligned with the real activity boundaries. So, the common strategies which are mostly used are fixed time windows, event driven windows, change point detection methods, and hybrid rule based schemes combining time based knowledge and knowledge driven heuristics. These approaches typically fix a single segmentation paradigm for all contexts. It requires manual tuning and may add computational overhead, especially change point detection methods. And it treats segmentation as a static pre-processing step despite context variability in real homes. So our objectives are to reframe segmentation as a supervised learning problem, learn which strategy to use in under which context, and to design a context-aware controller that selects between time-based, event-based, activity-based, and uh, strategies in real time. And it engineers the 44 numbers like context, feature space, capturing temporal, sensor behavior, environmental, and historical cues. Also evaluate the framework on we evaluated the framework on two data sets from the cases Aruba and H101 smart home data sets. So the background about what have been people doing in the literature, there are different techniques used for segmentation, like fixed time windows. It mostly dominates in this human activity recognition public applications. And then we have event-driven segmentation. It aligns windows with sensor activations and has shown gains over static. There is change point detection. It also improves the segmentation quality, but it also brings some computational costs overhead as well. There's adaptive sliding windows, knowledge driven, fuzzy temporal segmentation. And as in the recent times, deep learning got famous, people have used it as well to improve recognition, but it typically they used fixed segment mutation technique to train the deep learning models, and they also require large data sets for this purpose. The gaps which we were able to find were like the segmentation is often used fixed once and then reused across different homes, residents, and routines. Approaches generally do not learn to choose among multiple segmentation strategies based on the situation, and there's limited work on real-time resource constrained segmentation control suitable for edge deployment. So the data set which we have choose in this study were Aruba data set and HH101 data set. They were from the CASES project, Washington State University, that provided these data sets. And the Aruba had a single resident apartment recorded over 219 days. It had 10 binary sensors, and there were 1,602,821 time-stamped on and off events. There were 11 activities in total, and it provides us continuous 24/7 capture with routines ranging from long inactivity to rapid bursts. And similarly for HHH101 dataset, there was a multi-week smart home dataset. It provides these similar activities, and there was begin and activity annotation, which help us strong ground truth for boundary evaluation. This is our methodology which we proposed. We had feature extraction here. So after extracting the features from a data set, then we give it to a machine learning model. We used two models here, random forest and XGBoost, and that model learns and predicts the strategy, like which strategy we should use to recognize the human activity. And after learning about the strategy, then we apply a model on the data set to using that strategy to predict human activity recognition. So our core idea was to treat segmentation as strategy selection over a binary sensor event, not just as fix it and then use it. So we also compute a 44 numbers context feature vector X from rolling 500 event windows. And this we use two strategy predictors, random forest and XGBoost. What random forest gives us the best strategy accuracy, and there is adaptive segmenter. So whatever the best strategy random probability gives us, then we use it to in real time to create activity segments like time based or event based or hybrid, and then we then we do the recognition. We also do the XGBoost with 200 trees learning rate, 0.1 max depth or 6, and early stopping if the model has like stop at some age, like does not perform better with the existing performance, like it will stop. So We track the segmentation outcomes, which and it supports offline labeling, online uploads, and enables closed loop adoption. The overall system yields less than 1 ms decision latency per window. It is suitable for real-time system like home real-time smart home deployment. So this was our experimental setup. Here we used Aruba dataset. It was divided into 80% for training and 20% for testing in a chronological order to avoid the leakage of features. And then we also applied five-fold cross-validation on the training set to check the generalization of the model. The matrices which were used for strategy were strategy classifier were accuracy, precision, recall, F1 score. And then for the segmentation matrices on both dataset, we use boundary, precision, recall, F1 score, and normalized edit distance. It is a distance between predicted and ground truth activity sequences. And the lower it is more better, and the number of segments produced using the that strategy. So these are the results. Table 5, it is a segmentation result strategy result on Aruba. So if we have fixed 60 seconds, event-based and adaptive, and boundary precision, boundary recall, boundary F1, and NED and segments results here. If we see event-based has lowest NED score, it performs better, and segmentation on the HH101 dataset, again, we have event-based achieve the lowest NAD value. And then we do the strategy classifier on Aruba dataset using both models, and they both achieved a very good accuracy. These were the topmost 15 important features for strategy predictions. So the findings are like fixed 60-second windows are unsuitable for boundary localization because gives very high recall but very low precision and F1 score. Extreme over segmentation, 63,000 segments on Aruba dataset and 85,000 on HH11 dataset. Event-based segmentation is a strong replicable baseline because it has higher boundary F1 and lower NED than the fixed windows. It has fewer segments, making sequences more compactable while preserving boundaries. The context-aware controller, it yields the fewest segments but sacrifices in boundary F1, revealing a parsimony fidelity trade-off. The strategy predictor achieves near ceiling accuracy and with strongly diagonal confusion matrix. There were some minor confusions, mainly between event-based and hybrid approach. Though by implementing thorough context-aware segmentation with strategy selection guided by rich sensor pattern features, we obtain interpretable low latency decisions that can be tailored per deployment while avoiding static hand-tuned windows. So the limitations were there is a timing uncertainty in Aruba labels, possible bias from Oracle, parameter sensitivity, and because one data set contained a single resident and the other one was a two resident home, so that is also a limitation, and the binary sensors were only used in these data set to record, and there was no evaluation on wearable or richer multimodal sensing. So in the future work, we're going to develop hybrid adaptive event methods to recover boundary F1 while keeping the segments compact. Incorporate uncertainty aware decisions with fallback strategies, online adaptation to non-stationary sensor failures. Yes. And to extend the multi-resident scenarios, we will include more data set to which have more residents and the other like sensors as well. And in the conclusion, it re-examines segmentation for sensor-based for in smart homes, comparing fixed 60 and second windows, event-based segmentation, and context adaptive policy on two datasets, Aruba and HH11. Using boundary precision and NED segments, it counts that fixed windows are inadequate for precise boundaries, while event-based segmentation gives better boundaries. And we have higher accuracy strategy predictor and feature analysis. It highlights sensor pattern dynamics, especially state transitions or the main drivers of segmentation is with resulting generalization across both terms. So overall segmentation should be treated as context-aware learning problem, replacing fixed windows with event-based baselines and using hybrid adaptive policies to build more reliable, deployable human activity recognition pipelines. These are the references which we used in the paper and in the presentation. So I would like to thank you all for listening to my presentation. If you have any question, you can ask.
Thank you for your presentation. Any questions? No question. Thank you again.
Thank you. Thank you.
Well, we can move on the next one. Said Al-Khaleh. Are you
I'm
here?
here.
Okay.
Okay, let me share my screen. Good evening, everyone. I am Hassan Al-Hussein, and I will be presenting this study on behalf of my author and co-author. And first of all, many thanks to the committee for giving us this opportunity to present our study. Excuse me, this was the first page. Our study is about aspect-based sentiment analysis for hotel reviews. And first of all, what is sentiment analysis? Aspect-based sentiment analysis, or APSA, helps us understand not just how customers feel, but what exactly they feel about, such as cleanliness, service, or food in hotels. This is especially important in the hotel industry, where decisions rely heavily on detailed customer feedback. However, traditional APSA systems depend on large labeled data sets, and they struggle when domain changes, and they often fail to understand tricky language like sarcasm or idioms. These problems get even worse in multilingual environments. To overcome these issues, we introduce a zero-shot transformer-based APSA approach. The key idea is simple. Instead of training on thousands of labeled examples, we can use pre-trained large language models to infer sentiment directly from natural language prompts. This gives us a system that works across multiple languages, adapts to new domains, and handles complex expressions without the need for fine-tuning. Related work. Early APSA systems relied on lexicon methods and classical machine learning models such as SVMs. These methods worked for basic sentiment, but struggled with context, domain changes, and multilingual reviews. Transformer-based models like BERT and Roberta improved APSA by using contextual embeddings, but they still require domain-specific fine-tuning and large labeled datasets. More recent works explore zero-shot and prompt-based apps using large language models. These studies showed that instruction-tuned models can perform sentiment classification without fine-tuning. However, many of them still struggle with cross-lingual generalization and robustness to sarcasm or noisy language. Now, our work builds on this direction by applying zero-shot learning specifically to multilingual hotel reviews and evaluating the model's robustness under different linguistic variations. Proposed model, our system uses a simple but effective four-stage pipeline. First, we pre-process the text using normalization, tokenization, and named entity recognition to clean the review and prepare it for analysis. Second, we extract hotel-related aspects such as cleanliness or service quality using a hybrid method that combines keyword filtering and dependency parsing. And third, for each aspect, we generate natural language hypotheses, like the sentiment toward cleanliness is positive, for example. This reframes sentiment analysis as a natural language inference task. And finally, we pass the review and hypothesis into a pre-trained large language model. The model performs zero-shot classification, predicting whether each aspect sentiment is positive, negative, or neutral, without any labeled training data. This modular pipeline makes the system scalable, multilingual, and easily adaptable to new domains. And the sentiment inference process is performed through a hypothesis-driven zero-shot classification loop. The system generates a pair of natural language hypotheses, one with positive sentiment and another with negative. They are all evaluated using a pre-trained zero-shot classifier. The sentiment corresponding to the higher confidence score is selected as the predicted label. With this approach, we can make robust aspect-level sentiment analysis without domain-specific label data or fine-tuning, relying solely on the model's pre-trained language understanding capabilities. Now, for the experiments and the results, first of all, the experiment setup. We evaluated our system using publicly available hotel review datasets, each containing reviews describing key aspects such as cleanliness, room quality, and staff service, for example. We have the English dataset. We used the SAMeval 2016 hotel reviews dataset with an English translated version of the APSA Hotels Arabic dataset, which we also used. We also used it for our Arabic language training. The APSAML dataset. It contains over 2,000 hotel reviews and 24,000 annotated aspect sentiment pairs. And we also did for German and Spanish. We used reviews from the 515K hotel reviews in Europe dataset, and it contains 515,000 user-generated hotel reviews. Now, the baselines, we compared our system against three well-established methods. We compared it against the lexicon-based Vader analyzer, traditional machine learning, and deep learning BERT fine-tuned model. Our training experiments were conducted on Google Cloud TPU v4, and the BERT language model was used for zero-shot classification. Now, for the first experiment, in this experiment, our system is benchmarked against the baseline methods I spoke about in the previous slide. Using the English dataset, we can see that our proposed model outperforms all baseline metrics with an accuracy of 92% and an F1 score of 90%. The zero-shot approach is particularly effective in handling contextually ambiguous sentences, where both lexicon-based and shallow machine learning models struggle with. This confirms the advantage of leveraging the contextual understanding of pre-trained large language models without the need for domain-specific fine-tuning. And now for the second experiment, we assessed our system cross-lingual generalization capabilities to see whether or not it can infer aspect-level sentiments in multiple languages without language-specific fine-tuning or training data. The same hypothesis templates phrased in each target language were applied consistently across the experiments. And we can see here that the model performed very well across all 4 languages. This also confirms the model's multilingual generalization, successfully extending aspect-level sentiment classification to languages without task-specific labeled data, especially in the morphologically rich Arabic language. Now for statistical reporting and reproducibility. To ensure robustness of the model and reproducibility of our results, we followed these protocols. Each experiment was repeated 5 times with different random seeds, and performance metrics are reported as mean standard deviation in line with standard machine language evaluation methods. Paired two-tailed t-tests with significance level of 0.05 were applied to compare our zero-shot model against each baseline. And as shown in the table, we paired t-tests to confirm that zero-shot model significantly outperforms all baselines. In conclusion, our aim is to create transformer-based zero-shot learning framework for aspect-based sentiment analysis in the hospitality domain. By leveraging pre-trained LM models, our approach infers sentiment without requiring fine-tuning, addressing key challenges such as sarcasm and negation. Comprehensive experiments on hotel review datasets demonstrated that our method outperforms lexicon-based machine learning and fine-tuned deep learning baselines in accuracy and fine in sentiment. Multilingual tests confirmed the model's generalization capabilities across diverse languages with no need for the language-specific training data. And for our future work, we can expand the multilingual evaluation by incorporating the hotel subset of the recently released M/A apps dataset, which provides aspect sentiment triplets across 21 languages. Now, this will provide us with wider cross-lingual generalization studies beyond our current 4-language setup. These are our references, and thank you very much, everybody, for listening. If you have any questions, feel free to ask.
Thank you for your presentation.
No problem, sir.
Any questions? No question. Thank you again.
Thank you very much.
So next one is Ahmed Bakar. You
Yeah.
here?
Yeah, here.
Okay.
Thank you. Let me share
You can
my
start.
Yeah. You see my screen?
Yeah, it is visible.
Okay.
You can start.
Okay, thank you. Good evening, everyone. My name is Ahmed Bakir. I'm a QA Automation Team Lead. Today, I'm presenting our research titled A Comparative Evaluation of Cypress and Catalan Studio for Web Application Test Automation. Our work was carried out in collaboration with my colleagues, Sarah Shoke and Mohammed Saboube, under the supervision of Dr. Samir Zain at Birzeit University. Our goal in this study is to provide a practical insights into two of the most widely used web automation tools, which is Cypress and Catalan Studio, and to evaluate which of them performs better in the, let's say, modern testing environment, especially within the CI/CD pipelines. In today's software applications, applications are becoming more complex and release cycles becoming faster. This is, let's say, makes the automated testing more essential, and the automation helps us to detect the defects early and to reduce the manual effort to make sure that it's consistent and repeatable results, and to support fast release cycle in the modern agile and DevOps pipeline cycle. However, choosing the right automation tool is not always easy. Each tool offers, let's say, different challenges and limitations. The wrong selection, you can, let's say, it can slow down the project you are working on. So in this research, we are focusing on comparing these two tools, Cypress and Catalan, to understand their performance, their reliability, and if it's suitable for the real-world application, especially for the functional testing. Our main objective, let's say, the study goal is to conduct a fair, controlled comparison between Cypress and Catalan using the same web application we choose for testing and the same test cases which is applied for both Cypress and Catalan. So we evaluated both tools based on the execution speed, the integration with the CI/CD, which is the continuous integration, continuous delivery, the usability, debugging support, and how will they handle the dynamic web elements in this web application. So this is aims to help the QA teams to choose which is the most, let's say, tool fit for their context or for their applications. Here we summarize the core differences between Cypress and Catalan. For Cypress, it's a JavaScript based. It's always running directly inside the browser. It has a fast execution. It has automatic waiting for the locators and excellent for the debugging. If you have an issue, let's say, or if you're trying to debug something in the browser, it's ideal for teams comfortable with coding. While Catalan is built on Selenium and Appium, it's provide a user-friendly interfaces with keywords-driven testing. It supports web API, mobile, and desktop applications. It's great for teams with mixed technical background, so Both tools are powerful, but they, let's say, shine in different areas. To build a solid foundation for our study, we reviewed several relevant research papers. One of them for Vieira, which is in large CI/CD pipelines and highlights its maintainability and speed, while other research to check the ease of use in Catalan for the cross-platform automation. Other, let's say, research paper to show how Catalan improved testing speed in agile environments. For Fodal research, it's compared like 25 UI testing tools and found Cypress ideal for JavaScript for the heavy applications, while Catalan offered faster platform support. The last research, it shows the Cypress and how it's performed better with dynamic and asynchronous content compared to Selenium, which is the most topic that challenging in our real web applications. So these works show the tool choice depends on the context, on the team skills, on the system architecture also. So why we choose this system, which is called Orange HRM, we selected this system as an open source for our test application because it has a modern UI with dynamic elements. It has forms to validate or for validation. It has asynchronous behaviors inside the system. It behaves as a modular structure, which is very good for our testing. So it makes it a good candidate for evaluating how each tool handles these real-world testing conditions. Sorry. Sorry, by mistake. Okay, so we designed 50 functional test cases that covered the Orange HRM module, like the login, like the BIM module, the buzz module, and we took some general system flows. So these test cases include both positive and negative scenario, such as a valid input, invalid input, to check the error messages, to check the permissions, and etc. The most important thing that both tools executed the same test logic to ensure a fair, let's say, comparison between Cypress and Catalan. The methodology we use was simple and controlled. We implement the same test suite in both Catalan and Cypress. We executed both suites inside Jenkins to simulate a real CI/CD pipelines. We prepared each suite we have to be run 10 times to reduce noise and capture, let's say, the stable average. We collected execution time for pass and fail results and runtime behaviors. So this allowed us to compare the tools under identical conditions for the environments, for the number of test cases, for the number of test runs that we executed on this suite. For the design, we took, let's say, some of the test cases for each module, 38 for login, 4 for PIM, and 3 for buzz, 5 for the general, to ensure all interaction form submission, validation, asynchronous, the loading and the UI state changes were equally represented in the application. We executed each tool in isolated Jenkins pipeline. So we took Cypress as an isolated Jenkins pipeline, and for the same for the Catalan. Cypress produced report using the Allure plugin, while Catalan used a built-in reporting dashboard. Tracking these results over 10 execution runs allowed us to measure the execution time stability, the runtime reliability, and the CI/CD compatibility. And the setup reflects how teams run the automated test cases that they have in the real development environments. These are sample of these test cases. So let's go to the results. This This is the one of the most important findings for our study. Across all test runs 10 times in CI/CD, Cypress completed the test suite in 1 minute and 35 seconds, while Catalan required 4 minutes and 3 seconds, which means Cypress was approximately 2.56 times faster than Catalan. So in CI/CD workflow, where tests run many times per day, this is the difference, or this difference is very significant. Let's say for Cypress to be more faster by 2.5 times than Catalan. These are the results of Cypress and Catalan also for the CI/CD integration, how the Cypress behaves in the CI/CD integration, and the Catalan Studio, the reporting service, how Cypress support the plugins for reporting, screenshot and videos, while Catalan have a built-in dashboard, no screenshot only, limitation in the customization of the code, and etc. for sure for the project structure, for the test tagging, debugging, synchronous behavior, and cost and license. The data shows that Cypress offers several advantages. It has a faster execution. It has more stable test, automatic handling of asynchronous behavior, strong CI/CD support, and better debugging. Also with the time travel snapshots that Cypress takes from time to time. While Catalan remains very valuable, it supports tester with limited coding experience. It's offer built-in reporting and it supports mobile and API testing out of the box. So each tool still serve a different audience. Okay, so to conclude, Cypress is faster, more stable, and integrates very well with CI/CD. It's fit for JavaScript, heavy applications, and development-oriented teams, while Catalan Studio is better for teams with mixed skills and for projects requiring mobile or desktop automation. Both tools are useful, but Cypress is more suitable for, especially for the performance, when we talk about the performance, when we talk about CI/CD integration, and for debugging aspects are priority more and more for the engineers inside the team. So our final recommendation is to choose the tool that best match the team's skills, always the project's technologies stack and the organization testing tool. We have a future work for our study. We are planned to evaluate the tool on mobile API and cross-browser testing, to include the performance and security testing, especially for the core functionality inside the browser, compare long-term maintainability for both projects, investigate the AI-driven features like self-healing locators, and to test with other automation tools like Playwright, Selenium, or TestCafe. This would help to build more complete picture about the whole tools that we have. Thank you very much for your attention, and I would be happy to answer any questions if you have.
Thank you for your presentation. Any questions for this study? You are getting claps. So no question. Thank you again.
Thank you.
So the final one is Necip Gözü Açık.
Yes, I am here.
You can start by sharing your screen.
Okay, thank you. Can you see my screen?
Yes, it is visible.
I think, is it wrong? Let me check. Okay, can you see my screen, right?
Yes, it is visible. You can start.
Okay, thank you. Hello everyone. My name is Necip Gözaçık. I am from Siemens, Turkey. So today I'm going to present our work about transformer-based novelty scoring of research ideas and end-to-end NLP pipeline. So this is the outline of my presentation: introduction, related works, methodology, experimental results, and finalize with conclusion. So let's start with introduction, some problem statements. So we know that there is a rapid advancement for GenAI and large language models, and it's introduced many opportunities and challenges also in research and innovation, because now we can generate more ideas with use of these tools, but it is a bit hard to validate these groundbreaking publication ideas, that it's really a novel, or it is somehow another version of already idea. So numerous organizations are also actively engaging their innovation and innovation driving processes, like performing some ideation workshops or brainstorming sessions to generate novel project proposals and publication concepts. However, the ability here to accurately assess the novelty of such idea remains still a persistent challenge with the involving more actors there. So existing evaluation mechanisms here, for example, expert peer review or citation-based metrics, are often limited by subjectivity, inefficiency, and lack of stability. Here, advances in natural language processing, also LLM, is a subset of some part of this technology. With transformer-based architectures, they provide some promising avenue for addressing this gap. In this study, we introduce an end-to-end NLP pipeline that provides some novelty assessment, aiming to advance some automated research evaluation systems and support the pursuit of truly original contributions. So in this table, there are some summarization of some related works on this scientific novelty evaluation. As we can see, there are some traditional approaches. They use some metadata of some publications, and they are using some large data sets like Scopus Web of Science, but they may lack some semantic understanding. Also, there are some novel graph network modeling application areas. Also, machine learning or deep learning based approach also give some related works here, and also transformer voice models with LLMs like BERT or some version of LLMs also provide some items. And there are some tools or systems like, as I mentioned here, they provide some items there, but we cannot see the 100% solution for this item from this table. So what is the methodology in our solution here? Actually, the aim is systematically evaluate the novelty of research ideas, and we designed a multi-module framework that combines some automated literature collection, data organization, transformer-based similarity analysis. For example, this is the some architecture of our workflow of our proposed modules. It consists of 5 modules, and I will describe them one by one in upcoming slides. So let's start with input module. We designed that provides some 2 critical inputs for the user, like description of his research idea and the name of a target conference or journal. So this will give us which venue we should consider or compare this new project idea or publication idea. Collector module is responsible for building a comparison set. It queries an academic scholar database to extract the title and abstracts of publications from last 3 years here. We selected 3 years to make it more recent study, or to compare with more recent novelties on this area. For example, in this proposal, we used Web of Science as academic database, but it can be generalized with using some other databases like Elsevier, Semantic Scholar, or something like that. In organizer module, we structure and consolidate the data retrieved by the collector module. All publication titles and abstracts are merged into a single coherent data set, such as an Excel workbook. In similarity module, actually, this is the core of our proposed novelty assessment module. With this module, we merge title and abstract of the publication here as a new feature term, and we used here a pre-trained transformer module and employed to encode their textual inputs into high-dimensional embeddings, and to measure similarity with the user's proposal idea. We use cosine similarity metric here to calculate the similarity between requested or proposed idea with the existing works. And lastly, we have a scorer module. It translates our similarity scores into a novelty metric. Here, the maximum similarity score observed across all comparisons is identified, and as it represents the most closely related to prior work, and the novelty score is then computed using the formula like found maximum similarity score and subtracting from 1, it gives a hint about their novelty score. Let's talk about our experimental results. For this experimental study, we used selected a candidate journal here. For example, we selected technological forecasting and social change journal. It is a one of the high quality journals in Elsevier and in index with Scopus, and we collected 3 years data from 2022 and 2024, and we collected like 2,000 article records. To establish a reference baseline, we visualized most frequent occurring words across these titles abstracts in this figure. As we can see, since they are also related to target journal, so most frequent words here: innovation, study, technology, research, and digital, emerging as a dominant themes. But there are also some other areas or themes in the journal focus. So to be able to visualize this experiment, we prepared a draft study with using Streamlit framework, with using Python. In this first example scenario, for example, we give as a query, for example, our idea is sustainability for digital technology, and I would like to request what is the novelty of this proposal idea according to collected articles from this journal. This application computes novelty score as 1.27. So the relatively low score suggests that the idea has some limited novelty regard from the point of this journal focus. So it means some overlapping with existing research or widely discussed terms in the machinery journal. Maybe we can expand this idea with more details or use some other focus. In the second example, we use, for example, deep learning based traffic prediction. This is the proposal idea of the user. When we use this one, the application computes novelty score, for example, 1.5, sorry, 0.5. So it means it is a bit novel from the point of this journal according to current studies. So this mid-range score indicates that while the concept shows some originality, it also still overlaps with established research in traffic prediction. Probably there are some other AI or deep learning applications or research in this journal. So in this chart, we would like to compare the embedding vectors of our query 1, which is lower novelty, and query 2, the mid novelty, using the TSNE methodology is presented here. To simplify the illustration and enhance clarity, we selected on the top 100 entities from the title abstract column rather than the complete data set. We can see that query 1 here, we can see which has a lower novelty score is positioned in closer proximity to other title abstract embeddings. So that means that this is somehow similar to the current studies in this journal. So that is why it is proximity located here. But in query 2, it is a bit a part of this area. So it is a bit close to some other empty area. So it means it maybe provides a more novel idea according to this journal collected data. So as a conclusion, from the point of this study, we used NLP pipeline for this novelty assessment using transformer simulative, includes some literature retrieval, data structuring, and embedding comparison, providing some contextual evaluation against recent venue publications. We can say that if there's a high overlap, it means low novelty. If there's a less overlap, it is higher novelty. Uses transformer embeddings for scalable and interpretive scoring, but sure, there are some limitations here. For example, for this experimental study, we only used a single database and selected a single journal here, and also short time window. Maybe we can expand the window. In Outlook, there are some ideas like expand to multiple data sets and venues. Also adding some other domain adaptive embeddings, and maybe formulating the novelty formula in a more detailed way with including some other contributed logics there. And also we can use LLM based approach also in this study, so it can be expanded from this point way. So that is all I can say from this point of study. Thank you for your listening, and if there's any question, I can help.
Thank you for your presentation. That was pretty interesting. Any questions for this study? Probably not. Thank you for your presentations and your attendance to this symposium. So I would like to end this session here. So have a good night. Thank you.
Thank you for
Thank you all. Bye.
organizing. Thank you. Bye.